Hi, I'd like to welcome everyone to today's webinar. My name is Spencer Lee, and I'll be conducting the webinar this afternoon. The webinar should last roughly 45 minutes to 1 hour. So we're also going to record the session, and the recording of the webinar will be placed in the ADAPT webinars playlist on our YouTube channel, which is at www.youtube/ADAPT-Support, and you can go to that particular playlist. We put all of the different webinars on that location, so you can always go back and review what we covered today. Everyone should be seeing the Etabs screen here with the model we're going to use in today's session. And just a couple of announcements. If you have any questions, there should be a question option in the panel on your on the floating GoToWebinar panel that you should see on your end. If you have a question, just go ahead and type it in. We'll try to answer all questions. Also, if you have any specific questions that might be related to a model that you're working on or troubleshooting of a model, if we can, we would ask we can reserve those for the end of the webinar or just aside at a different time using our typical support channels. So let's go ahead and get started. Today we're going to cover the ADAPT Integration Console version 5, and we're going to use a multi-story example here. It's not terribly complex, just for the sake of time we're using something a bit more simplified, but we're going to cover a few different workflows and cover some of the capabilities of being able to use that tool integrating Etabs models with ADAPT-Builder. And the use of the tool is dependent on the Etabs models you have currently in place. So the Integration Console version 5 is compatible with Etabs 2016, Etabs 2015, and also older versions of Etabs version 9. And we also have the ability to integrate with STAAD to some level. There are limitations to the integration console. Some of those limitations are the program will import gravity loads and reactions, as well as lateral static loads and reactions. If we try to import let's say, response spectrum type results from Etabs, results that are not in equilibrium, we cannot apply those in our program in ADAPT-Builder because the loads are not in equilibrium, so we get an error if you try to rerun, for example, a single level analysis using those loads that are imported in which are not in equilibrium. So that is one limitation. It's really used currently for lateral static and gravity loads. You can import geometry, an entire model if needed, the entire model or specific levels into Builder. You can import applied loading. The applied loading option does require us to generate an additional file, which we'll show here at the onset of using the tool, and then also reactions, internal wall and column reactions. So the first thing we're going to do, we're going to assume that we want to import applied lateral loads, for example, out of the Etabs model, in addition to those other options, geometry and reactions. And this model has been solved. We're just going to go up here to File, and we'll go to Export. We're going to export an XML file, and we'll go to Analysis, Results, and Structure Result, and I'm going to select Story Forces. So we need to know the story forces to be applied per the lateral load cases out of Etabs. We'll say OK. I'll just change the length and the force unit from inches to feet and kip, and go ahead and save that. I have that file. I'll just overwrite the file we have here now. So we'll save that XML file, and now I'm just going to close Etabs. So to use our link, you must have an active license of Etabs available. So if our link will automatically open Etabs API and access that tool, and in order to do that you have to have an active license. So we'll go ahead now and launch the ADAPT Integration Console. And these are the steps that we would use to generate the input file, the generic adapt input file that is needed to generate the model or to update a model with the reactions from Etabs. So we're going to select Etabs 16, and you can see 16 and 15. These essentially produce the same result out of this console using the API in Etabs. Older versions of Etabs use input-output files that the user has to generate. So the input in this console might look different and have different selections depending on what you select in this opening screen. The first step, we'll go ahead and select Next, and we want to load the model that we're going to access. So we'll go to Browse, and I'll just browse to that same model that I was just looking at. This is an EDB format, and I'm going to first load the model. Now when we load the model, the program will access the Etabs license. It will launch the file. The user doesn't need to close the file. If you close it, it could interrupt the extraction of the data. So just allow the program to open Etabs, and then it will automatically close Etabs when it's completed. Files that are heavier in terms of data and load combinations, just a heavier model in Etabs will result in longer runtime for this particular part of the application. So it could be seconds or it could be minutes depending on how large the Etabs file is. And we'll just go ahead and wait. So that's done. Etabs is closed. Now at this point I have the ability to select my import options. I can select all of my levels or I can select individual levels. An example of using individual level data might be if you have a transfer slab that you're designing in Builder for gravity loads and for post-tensioning, for example, and you want to introduce lateral reactions into the frame, in the columns or walls within Builder. You could choose to import only one level and one set of data. In our case, we're going to choose all levels. So we're going to build a brand new model from the Etabs file. And if I don't select the StoryForce option and I just continue with the creation of this adapt exchange file, the program will produce a file that includes geometry and reactions, but no applied loads. And this is a pretty common scenario where we don't really care about importing the lateral loads into Builder, but we just want the reactions and to build a model from the Etabs file. So we're going to take it a step further than what's typically common with the usage of this tool, and we're going to select the XML file. So we'll go ahead and browse to that file that I created at the onset of the session here. Once that file is loaded, I'm going to create my adapt exchange file. So any of you that are familiar with our linkage tools, for example with Revit or older versions of our Etabs console, and also internally or native to ADAPT, if you wanted to extract a model IMP file for a specific ADAPT model, you could create an IMP, open and import the IMP in another instance of Builder and regenerate the model within Builder. And we are currently actively working on being able to also write tendon data to the IMP file. That should be available in the 2017 release of Builder, which is tentatively scheduled for early September, so about a month from now. And we also have other features that are coming out with that. I'll just mention those briefly. We have some very significant improvements to tendon modeling and optimization in the program, as well as wall design. And a few weeks ago, we did do a webinar related to tendon optimization. So if you haven't seen that, that will be placed on that YouTube channel as well in terms of the webinars that are reproduced there. Okay, after the IMP file is created, we're going to get this message just stating it's done successfully, or for some reason, if it wasn't successful, it will provide that message. Here we have a good file, so we'll say OK, and I can now just close down those windows. And I'm going to launch ADAPT-Builder. And in Builder, because I'm importing a full model that I might need the ability to analyze the entire frame, multi-level frame, I'm going to make sure I have Edge selected, which is just our frame analysis engine, and Floor Pro gives us the ability to design elevated floors, and also you could design foundations with Floor Pro as well. You don't technically need mat at this point to design the footings or foundations, so we'll go ahead and say OK. I'll go over to File, and I'm immediately going to import this generic adapt file, the .imp file that I had created previous. So let's go over here to the folder that's contained in. And this is my IMP file that was just generated. So we'll go ahead and select that. When that's selected, the program will open our generic import options. So when you import a file from Etabs, a file from Revit, a file from STAD that might be produced through the integration console, you're going to see this import options. Even a file within ADAPT, if you created an IMP of one model and imported it into a new instance, these are the options that we would see. The first thing we'll do is just go ahead and select all of our levels. So we're going to create a new model versus update a model. You'll notice that when we do that, all of the components, we have a component count, but we can't edit any of the components. So this doesn't allow us to filter out columns, slabs, whatever component we might want to disregard in the creation of the new file. If we use an individual level, then these become active and the user can filter out specific components level by level. But for a full model, you can't filter. If I go to update a level, notice that all is no longer available. So here you can only update one level at a time if you use the option to update. Okay, the loads and load cases. Here the program will list all of the load cases that are being imported from Etabs. So we have a few gravity cases, EQX, EQY, just some basic wind cases here, and the type of load case that's being imported. So we have options on what to import. So we can import forces and reactions, applied forces only, reactions only, or set it to no if we don't want to import a particular case. We can also map cases to already defined load cases inside of the builder model. So for example, the default load cases in this builder model will be dead load, live load, self-weight, pre-stressing, hyperstatic, or secondary, and we can map any of these loads to one of those particular load cases if they are already defined. For the lateral loads that are being imported, the program will allow us to define an eccentricity that is basically tied to the particular lateral case, the applied force, and that can be modified after the fact, but we'll just leave it now at 5%, and then I'll show you where those are stored in the builder model. So let's go ahead and create this model. We have our model in place now, and just a quick review of this file. If I go to the rendered view, you can see it's basically the same model as what I had inside of Etabs. The program does not map any stiffness modifiers or any special conditions, release conditions at ends of columns or walls. It just uses the default condition that's set in the file within ADAPT. So for example, let me go ahead and turn this set of loads off here. If I look at a column and I go up to release, you can see none of the releases are selected. Stiffness modifiers, the default stiffness case in ADAPT, or the usage case we call it, is uncracked, and that's just set to 1. That cannot be edited. If you wanted to define a new usage case in ADAPT for the purpose of analyzing the frame, we could always go ahead and just edit the usage here, and then I'll just add one case here. We'll just call this stiffness 50, and I could go back now and change these one by one, which is not a great use of time. So what I'll do is I'll select all of my columns at once using select by type. And we'll go up here to columns, and then I'll modify the columns at one time. So I've selected the group of columns. I'll go to the column tab, stiffness, and you can have as many usage cases as needed. The nice thing is the program retains the reactions in walls and columns for every usage analysis case that's been run. So if you did 5 usage cases, you technically could recall those 5 sets of reactions for a rerun of a single level in any model. And there's a way to purge the reactions, but by default the program will automatically retain the reactions for any usage case. So here I'm just going to set these all to 0.5, just kind of arbitrarily use a value for columns. I'll leave the S11 at 1. Flexure and torsion I'll set to 0.5. And now if I was to rerun this model under Analyze for whatever set of combinations I want to rerun it for, you can see that the usage case is added here to the Apply Stiffness Modifier selection. So I have uncracked and I now have stiffness 50. And so either of these could be run globally or in single level when I rerun the model. Now the loads that were brought in from Etabs, we're going to review the loads now. So we go to loading in the load case library, we can see that there's reserved load cases that are defaulted to in ADAPT, which are dead load and live load. But I also have dead and live. Those are the imported gravity load cases from Etabs. So to avoid confusion in setting up my load combinations and how those are defined, because I also imported several load combos in from Etabs, I'm just going to turn off the reserved load cases in ADAPT. So I'm not going to use them. So I'll go ahead and turn off dead and live. And this message is just saying any load combination or pattern that's defined using these are going to be deleted. That's okay. We'll say yes. By default, lateral loads, lateral static loads that are imported from Etabs are imported as building loads. And the differentiation between general load and building load in ADAPT is that building loads are only solved for when we run the model globally inside of the program. So I'll give you an example of this. If we go ahead and say OK, right now we're looking at the structure in what we call full structure mode or global mode or multi-story mode. Those all mean the same thing. If I go to single level mode, you can see we can go to any level and we could run the analysis for that level independent of the entire structure. And the program will use different boundary or support conditions depending on which mode you're in. So in the criteria under the analysis and design options, for single level mode, the program uses this condition, and again the user could modify that if he or she needs to. And the multi-level mode or global mode uses a different condition. And by default, the multi-level mode is fixed at the base of columns and walls. And that can be manipulated. The user can user define. For example, if you wanted the walls fixed and the columns pinned, you can go in and modify that, and the program will retain the user modification and store that until it's overwritten at some point or deleted. So if we go into the load combinations input window, we have a few combinations here that are just the defaults based on the load or the design code that has been selected. So I'm just going to delete these first few combos. These are, again, just the defaults. I'll delete those, and we're essentially left with the combinations that were imported from Etabs. And you'll notice that the gravity loads that were imported from Etabs are assigned a factor, and then there's EQX and EQY. None of the wind cases are actually assigned a factor at this point. So we're going to test this model before we look at a few other load or a few other workflows, and I'll just set this to no code check, and I'm going to set this up for, I'll just call this test X wind. And I'll set the factor 1 times wind, wind X1. And there's no gravity load assigned, it's just wind in the orthogonal x direction, positive direction. If I now, let me go back to the multi-story mode, I'll mesh the structure, and I'll set this to something relatively high, just so we can speed through the analysis a bit faster. And it's just cycling through each level, meshing each of the levels automatically. Okay, so this is our mesh. But by the way, if you ever wanted to use a more uniform mesh, you have the option under Criteria, Analysis and Design Options. You can change it from sparse over to uniform. And the potential is there for the shells to be a little bit smaller, just depending on other constraints and the algorithm in terms of how it's meshed. But you have the ability to produce a uniform mesh as well. I'm going to go ahead and save this. Okay, and if I go to single level mode and I try to run the analysis for this single level for that load case, which I just defined as test wind X, you'll notice it's not even listed because I can't run a building load in single level analysis. Number one, it doesn't make sense to run a global, let's say, story force in a single level when it technically belongs to a range of floors in terms of the analysis. So it's not even there, it's not even listed. If I go back to global mode, I go to FEM and analyze, you're going to see that the load combination is now shown, because the only load case assigned within the combination is a building load case. Therefore, if we're in global mode, it will be listed. If not, it won't be listed. So that's something to keep your eye on. So we're going to switch gears now, and in the model, the program imported gravity loads. And what we want to do is make a comparison between the imported reactions due to gravity, let's just say dead load and live load, the imported reactions due to gravity from the finite element analysis in Etabs, and we're going to compare that with a tributary load takedown tool within Builder. The tributary load takedown tool has really nothing to do with finite elements. It's purely based on a geometrical algorithm that allows the program to subdivide the frame into tributaries, and it produces global takedown results for columns and walls. And the usefulness of it might be to collect service loads for sizing foundations, for sizing columns. Within just a few weeks, it could be used to design walls, to get preliminary wall designs. So it's a nice, quick tool to allow the user to quickly gather that information without having to go through the steps of meshing slabs and potentially troubleshooting meshing of slabs, or being able to run a model using the finite element engine within the program. And so what we'll do, I'm going to go ahead and turn off my walls and columns, and I'll rotate this model slightly so we can kind of see all the columns. I'll focus on these two column stacks out here on the edge here. And I will open the result display settings. Let me slide that over there. So in the result display settings, we've already imported the reactions from Etabs, and the program actually stores those reactions here. And you can see there's dead, EQX, live, wind, and so on. So that information is in a file somewhere. We can recall that graphically, or actually reapply those reactions for a single level run at this point, as long as it's included in a combination that we run. So if I navigate up here to column actions, for example, there's two different options, and I'll highlight these with my marker. There's column action using combination, and there's column action using load case. Combination is here. Notice it's blank because we haven't run the global model yet, so there's actually no solution for combinations, but there are solutions for load cases because those are the reactions that we imported from Etabs. So we're going to use those reactions now. And if I go to column load case, I'll just go to axial load, and you'll notice for dead load, the reaction brought in from Etabs here is like 328 and 328. They're the same reaction. So I want to compare the finite element solution, which is this, from Etabs with our load takedown tool in ADAPT, just to make sure that they seem on par with one another, the two models and the two solutions potentially. So let's go up here to, we're going to go up here to loading, tributary loads, and I'm going to use this tributary load tool to regenerate the tributaries in our model and also to calculate the load takedown in the model. So that's done. I'll go back to my default display, turn the slabs on just for a moment, and I'm also going to turn off the reactions that I was showing earlier. So the reaction was 328 for dead load. That's self-weight plus dead load. And now I'll turn on the load takedown tributaries. So if I go to the load takedown branch in this tree structure here, we'll go to tributary boundary, and I'm going to look at cumulative loads and let's say cumulative area. And this data is also available in the form of like an Excel spreadsheet. So all of this is tabulated in a spreadsheet as well. We can always go to reports, XLS reports, column tributary. Let me go into single level mode and I'll go back to a plan view. And we're looking at these two columns on the outside. So this is going to list our cumulative dead, live load, self-weight, cumulative area, and facade length on the perimeter. And if I just scroll down, you can see the load building. So looking at the tributary load takedown reactions, if I sum the dead load, this is superimposed dead 28.3 with the self-weight, which is 318, we get a reaction at the base of 346 kips. That's the tributary solution in ADAPT. ADAPT can also run a finite element solution, but we just haven't done that yet. So we're just comparing 346 to the solution from Etabs, and if I turn that back on, up here under column axial, you can see it's 328. So we're off by roughly 5% in terms of the difference between their FEM solution and just ADAPT's quick tributary solution in the program. So that's something that we wanted to show, just so you're aware that that tool is there. It obviously can be used for more than just comparative check of results. I can use these tributary loads to actually design columns or walls in ADAPT-Builder. So if I had my columns set up currently as a section type to process a design or a code check of the column design, in the component design options, my force source for designing those columns could be the tributary method, which means it's only gravity load only. But at this point, without even running finite element in the program, I could produce a very rough, let's say, preliminary design of the columns just based on the tributary takedown tool. Okay, so I'm going to pause there. If there are any questions, again, you should have a function where you can ask questions. Let me know, please, if there are any questions. And other than that, we'll go ahead and continue. Okay. So the next thing we'll look at, let me go ahead and clear some of this information here. I'm going to select loading, and we're going to go down here to load case. Let's go add load, and down here to lateral load. So in ADAPT can generate wind and seismic loads. The seismic loads is not super advanced. We're working on improving that and just adding more features. Currently, it's limited again to lateral static types of loads. So we realize that that's not super useful in some areas of the country or globally for design, but it is useful in other areas. So there are options here to use our wizards to generate those loads in the software. We also have a generic option that could be any load, but it's based on story force, and it is the way that we assign and calculate seismic loads in the program when we use the seismic load wizard. So these two functions are essentially based on the same underlying methodology, or let's say programmatic ability in the program. The wind load wizard, when we use the wind load wizard, that actually applies externally applied loads similar to a line load or a patch load or a point load. We discretize those loads into frame elements or into shells, and then we run the analysis. Seismic load and lateral load work a little bit different. So if I go to lateral load and I'm going to select update existing load case, this just lets me review the load cases that are already in place. So if I look at this list, this includes all of the imported lateral loads that were imported from Etabs. So there's EQX, WindX 1 through 12, WindY 1 through 12. And if I just randomly select here, you're going to see that the force that's shown here, this story force, is what was imported from Etabs. Notice the direction is set. The eccentricity is actually set from the input when we imported the loads, but the user can select and modify this and then update, apply it to the load case that you've selected. So this eccentricity here is related to this percentage and is dependent on the angle and what the projected width of the slab is. But these load cases are solved for as follows. At each floor we have some story force. The program takes an individual shell or frame element, and it takes the mass of that element based on this equation. So we're only considering self-weight. I could always go in and edit this and add dead load if I wanted to, or live load to the total mass equation here. But the program takes a ratio of individual shell mass divided by the total mass of the floor, and it uses that ratio and that percentage of the total story force and applies it internally to the shell and frame nodes. And so when we solve these load cases, we first have to know what the node numbers are, what the frame numbers are, and that happens when you press analyze. At that immediate point, the program numbers all the frames, numbers all the shells, and then it can assign these nodal forces to those particular elements. So if you apply these load cases and I say close, nothing appears to happen because we don't see all these loads externally applied on the building, and that's again because of how we solve those load cases. But the point is, when you import those loads from Etabs, those loads are stored as generic lateral loads and are solved for in that respect. So the user could take those loads, apply those load cases, build load combinations in the program using those load cases, and reapply them and solve them using our frame engine in Builder. So one such example, we just set up a load case for, let me just go here under combos to refresh here. We set up this load case for 1 times wind in the X right here. So that is a lateral load. It's a building load. It has to be solved for globally. And so we'll go ahead now and solve for that load case. We'll go to Analyze Structure. I'm going to select just that one combination, just a very simple combo. I'll run it without vibration analysis, and I'm using just the uncracked state for the solution. So go ahead and say OK. While these models are running, this should only take a minute or so, but while it's running, if you have any questions, again, this is a good time for any questions that you might have. Okay, so that's completed. We'll say yes to saving that. And now we have a solution for just wind in the X direction, which technically could be compared now to the solution in Etabs. So if we go, you'll notice that the combination now fills out with what was solved, which is test wind X. If I go to the load, the forces in columns again, for example, we'll do bending about local S-axis. And let me just go back and isolate the columns. You can see the force shown here. This is the wind X solution in the run for ADAPT. And there was actually quite a bit of difference between the wind X, between ADAPT and Etabs. It looked more than what I anticipated, so I haven't gone back and compared it with what the settings in that other model. But on a load case level, if I select wind X and I look at the reaction from Etabs, and I'll go down here and select moment about S, or yeah, moment about S, you can see the reaction due to the Etabs was 5.75. Make sure that's the right column. And if I go back and look at the reaction in Builder under the combination tab, we have 28. So obviously there's a pretty big difference there. It's a significant difference. And again, it could be due to some setting in the Etabs model that may not be reflective in this model. I just haven't compared the two the sources, I'll call them. So, but that's how you could compare one-to-one lateral reactions from Etabs versus the global solution in Builder. Now, one of the most commonly used workflows is the ability to rerun a single level in Builder with the reactions from Etabs. And that's what we're going to look at next. So I'll go and navigate over here to the 4th floor in this building. And for a moment, let's just assume that the gravity loads in this model, the dead and live load shown here, are produced. They were modeled inside of Builder. That's something that's easy to do. People can model, these loads in Builder, and you might have snow, roof live load, mechanical load, other superimposed dead loads. But let's just say that these loads are all defined inside of this program, and we wanted to combine the solution between the gravity loads and lateral reactions within or the lateral reactions that stem from the Etabs model. So in a single level environment, if I go back to FEM and I'll analyze the structure, and let's just go ahead and select a few of these combinations. So I'll select some of these ultimate design combos that include both gravity and lateral. So this includes dead load, live load, EQX, and this is reverse direction EQX, and then we have the Y directions as well. So we have 4 combinations that include gravity, which again is we're assuming has been defined in Builder, but it also includes EQX, which we're going to use the reaction from Etabs because that was our lateral model. We want to use that in this instance of the program. I'll select those combinations. I have the ability now to include the lateral reactions. And I could also include gravity reactions as well if I wanted to, but we're gonna solve the gravity reactions directly within the single level run, but at the frame elements, the columns and walls, internally to those elements, we have these reactions from Etabs. So I include lateral reactions. EQX and EQY are listed. Whatever lateral reaction or lateral load case is selected, those will be listed here in this box. And so the solution depends on the user's selection. So if I look at the solution, notice that Etabs is my only current solution. If I had run a solution native to Builder in global mode for EQX or EQY using uncracked or stiffness 50, those would also be listed in this box, and you could select Etabs, uncracked, or stiffness 50. But I haven't yet run this particular load case globally in Builder, hence Etabs is the only selection that's available. So we're going to use the Etabs reactions for the lateral case. We're using the direct solution for the gravity just due to the single level rerun. And I'll go ahead and say OK. I'll run this model. So that that's completed, and at this point I have just raw frame results. I can look at slab contours, you know, wall and column diagrams, axial moments, etc. But let's assume we wanted to design part of the floor with those load combinations that I just ran. So the next step would be something that I think a lot of you are familiar with, setting up, let's say, design strips within a particular floor region or the entire floor. And I'll just set it up for a portion, just one strip here. And I'll make this strip kind of strange looking, just for a little bit of fun. So these are our splitters. This is going to bound this one strip off from the rest of the floor. And I'll go ahead and generate my design cuts. And you can see my design cuts are shown. Now, when I design these cuts, they're relative to the solution from those 4 combinations that I just ran, which included native loads inside a builder and reactions from Etabs. So we'll go now and generate or design the design cuts. I now have a solution in place for these design strips for these 4 combinations that we ran. I could review, for example, bending moments, shears, axial forces, etc. for those particular combos. But ultimately, we might want reinforcement in the slab relative to those actions due to the combos. And we'll go ahead and generate our rebar. So this reinforcement, there's no rebars is required for those particular combos. You might say, well why? There's no post-tensioning in the model. Where is the capacity coming from? Well, if I go back to load combos, you'll notice that these are all defaulted to no code check. So I needed to really come back and set these to strength. These are strength combos, so I just forgot to set those. But that would give you the reinforcing in the slab due to those combinations. Okay, the last thing I wanted to show today was how would we go about designing columns relative to the same set of actions that are basically a mix between ADAPT, gravity loads, and Etabs lateral loads. So at this same level that we're looking at, if I just look at these 2 perimeter columns again, I have no section type currently defining those columns. So I'll just select those 2, and I'll create a design group out of those 2 columns. And I could select more and assign them to the same design group, but just to boil this down, we'll go ahead and select just those 2. I'll go to the option for modify the properties of the columns, and we'll go to column. I'm going to go to the design group, and I'll generate and auto-assign a new group for these 2. Now if I look at the column again, it's now called a 21.99 circular column. That design group is stored under the Build Section Type Manager window, and I'm going to rename it. I don't like the name of it, so we're going to say 22-inch circular perimeter column. And I can now define the reinforcement and properties relative to that section type. So I can define, for example, the dimension. It was too precise, 21.99, so we'll say it's just 22. Clear cover, 2 inches. We can assign effective lengths for the particular column, but there's all sorts of options here. We won't look at each one of these. The configuration we're going to use is circular, and we'll go ahead and produce 7 bars, and we'll use number 8 bars. Okay, and then we have ties here, so the tie size we'll say is a number 4 or the number 3 tie. So we define our section, and we can either design or we can code check the section. So we're going to code check this particular section. I'll say OK. That defines that reinforcement related to this particular set of columns, these 2 columns that are assigned to that group. The second step would be to set up our component design options. So I have the program is set up to design those columns for the 4 combinations that were listed. Whatever forces are produced from these combinations will be used to design the column. I can set up my design parameters down below. So for example, the force source, we have different options here, but we're going to use the finite element solution in ADAPT, which again includes the rerun of our native gravity loads plus the Etabs lateral loads, or lateral reactions rather. The level analysis governs. We just ran it in single level, so we're going to use level analysis. And if you have post-tensioning, the PT, you can also determine which analysis governs either level or global for the hyperstatic or secondary effects from the post-tensioning. So that's one thing that you can do, is you can account for those secondary effects when you design columns inside of a builder without jumping through any hoops or trying to mimic equivalent loading due to the PT or secondary actions due to the PT. And then there are other design-related parameters here and optimization constraints. So we're going to go ahead and just leave those as they are. We'll say OK. And at this point, if we have an active license of S-Concrete, we can select those two columns, or we can go to FEM, code check the components. I'll code check 2 out of 2 columns that are assigned to this particular group. The program will then go through the process of, on the back end, which obviously you don't see, it's opening S-Concrete. That license has to be in place and available. It's code checking these columns, and then it will return the results inside a builder without you ever needing to actually open that program. So we're utilizing their column design engine on the back end. So these are done. If I go to a column, right-click, look at the design summary, I can then produce a summary of the design for those columns that were just code checked. So this is the summary for this column. I could do the same one for this column, or I could design it. I don't have to code check. I could directly design the column using S-Concrete. But ultimately, those columns can be designed using a mix between loads and reactions from Etabs. That will conclude today's webinar. I'll stay online just for a few minutes. If there are any questions, I'll wait a minute or two to see if there are any questions that come in. But I appreciate everyone's attendance today. Again, just a reminder, the recording of this session will be placed on our YouTube channel. If you have any questions about the link is free, so if you don't have the link, you're welcome to email us at support@adaptsoft.com, and we'll send you the download for the link. If you have any other questions, you can contact support@adaptsoft.com. I thank you. Okay, so it looks like somebody was raising their hand for a question. If you type the question into the box, the question is, can the shear walls be checked in S-Concrete as well? The answer is yes. I'll show you an internal version of this. This is an internal version of the program as it is today. So this is the version that includes Wall Designer. But if I open this program and Wall Designer, we basically have 2 engines for designing walls. One of them is the S-Concrete link, but one of them is native to ADAPT-Builder. The S-Concrete link allows you to do a little bit more with wall design than what we've produced internally. For example, if we go here to FEM and I go to the wall design, this is something none of you have seen, so this is still in the works. This again will be released in mid to early to mid-September. But this wall designer, if I go to design parameters, the design tool that can be used is either ADAPT Wall Designer or S-Concrete. So you can actually link the wall design also with S-Concrete. And S-Concrete just has capability to do different shapes of walls. For example, if you had boundary elements, which are dumbbells essentially, you have to use S-Concrete. We don't support that in the ADAPT Wall Designer yet. So there are a few things like that that are different between the 2 tools that can be utilized. Other questions? Okay, looks like there are no other questions. Again, I appreciate everyone's attendance today, and if you have any questions, please let us know, and have a great weekend. Thank you.